In this video, we're going to go over some trigonometric equations, and we're going to apply what we learned in the last few videos to some questions and some problems. So let's start out with an example here. So let's say we have a right-angled triangle, which we will recall is a triangle that has a right angle, a 90-degree angle. So we have our 90-degree angle here. And let's say we're given the value of this angle, and that value is 42 degrees. And we're also given the length of the opposite side to the angle. So we're given the length of this side, and that is 80 units. And let's say you're asked to determine the value of this side here, denoted by an x. So you're asked to find the value of x. How would you go about doing that? So since we have this angle here, we have the value of this theta, and we have the opposite side, and we need to figure out the hypotenuse. We know that this side is the hypotenuse, it's the longest side, and it's the side opposite our right angle, opposite our 90-degree angle here. So one thing that comes to mind is using the sine function. We know that sine theta is equal to the opposite side over the hypotenuse side. And since we have the value of theta and we have our opposite side, we will only have one variable in this, which will be the hypotenuse side, and we can solve for that. So let's set this up in terms of our actual values that we're given here. So we know that sine of 42 degrees is equal to the opposite side, which is 80, over the hypotenuse side, which is x. Now, if we want to isolate for our x, we're going to have to get it out of the denominator. So let's say we multiply both sides of this equation by x. We're going to get x sine 42 is equal to 80. And if we want to isolate for x, we can divide both sides by sine 42. So we're going to get x is equal to 80 over sine of 42 degrees. Now, if you take out your calculator and plug this into your calculator, you can plug it in as exactly as it is here. 80 divided by, press the sine button and enter 42 in the brackets. Another thing to make sure is that your calculator is in degrees. You have the option to set your calculator in degrees or in radians, and you want to make sure that your calculator is in the degrees setting. So if you put this into your calculator as 80 over sine 42, you should get that x is equal to 119.558, or we can round that off to 119.6. So the length of this side is going to be 119.6 units. Let's go over another example. Let's say again you are given a right angle triangle. Here we have a theta which is unknown. We're given the length of this side as 80 units, and we're given the length of this side as 30 units. And let's say we are asked to determine what the value of theta is. What is the value of theta? How would we go about doing that? So right now, if we look at it, we are given an unknown theta, and we are given the values of the opposite side and the adjacent side. We don't have a value for the hypotenuse, but if we wanted to figure it out, we could using Pythagorean theorem. But for this question, we don't actually need the length of the hypotenuse side to solve this question. We know that our tan function, tan theta, is equal to the opposite side over the adjacent side. And we're given the values of our opposite side and of our adjacent side. So we can determine the value of theta just using these two values right here. So let's figure that out. Let's say tan theta is equal to, well, the opposite side to this theta here is 30, and the adjacent side here is 80. So tan theta is equal to 30 over 80, or you can simplify this to 3 over 8, or as a decimal, that would be equal to 0.375. So now we have that tan theta is equal to 0.375, or 3 over 8. And the way that you can determine the value of theta now is to use the arctan function. And on your calculator, if you press the shift button and then the tan button, it's going to select a function that looks like this. It looks like tan negative 1. So this is the arctan function. If you're putting it into a computer, you can also put that in as arctan. But essentially what that means is if you press this button, the shift and then the tan button, which is going to select this function, which is also known as the arctan function. What that means is that you can put in a value for tan theta, and it's going to tell you the actual angle that makes that value true. So if you press this tan negative 1 function or the arctan function and put in 0.375 into the brackets, then it should tell you the value of theta. And if you do that in your calculator, or if you're using a computer, you can type in arctan 0.375 and it should give you the answer, which is that theta is equal to 20.56 degrees. So that is going to be how you figure out a value for theta if you are given that tan theta is equal to a certain number. And this is true for sine and cosine as well. You are going to see this option for the sine, cosine, and tangent functions. If you press shift on your calculator and press any of your sine, cosine, or tangent functions, you should see that this is what you're going to get as your input. It's going to be either sine negative 1, cosine negative 1, or tan negative 1. And if you're using a computer and not a calculator, you can use arctan, you can use arcsine, or arccos. It's just ARC and then sine, cosine, or tangent, and that's going to give you the value of your angle. And another thing to make 100% certain of is that your calculator is set to the degrees mode and not the radians mode, because you can get a value of an angle in either degrees or in radians, and it's important to make sure that whatever you're looking for, whether you're looking for degrees or whether you're looking for radians, that your calculator is put into that respective function. Let's go over another example. Let's say you had a question that said if sine theta is equal to 0.2, what is theta? So you're told that sine of theta is equal to 0.2. And you're asked to determine the value of theta. So this is similar to the previous question that we just did when we were given a value for tan of that angle and we had to determine the value of the angle. Here, we're given a value for sine theta, and we want to determine what that theta is if sine theta is equal to 0.2. So what we're going to do is very similar to what we did in our previous example. Here, if you had a calculator, you would press shift and you would press the sine button, and that would give you this sine negative 1 function. Or if you're using a computer, then you can type in arcsine, and if you put in 0.2 for sine negative 1 or arcsine 0.2, so let's say we did sine negative 1 of 0.2 or arcsine 0.2, and we make sure that our calculator is set to degrees, then we should get a value for theta, and our value for theta is 11.54 degrees. Let's go over one last example. So this question is asking, if cos theta is equal to 1/2, what is sine theta? So we're given a value for cos theta, and we're asked to figure out what sine theta is. So the first thing that we can do when we have a question like this is set up our triangle so we can get a visual of what this can look like. So let's set up a right angle triangle here. Here we have our right angle, our 90-degree angle. Here we have our hypotenuse, and we're told if, let's say this is our theta, we're told that cos theta is 1/2. Cos theta is equal to adjacent over hypotenuse. So that means that our adjacent side will have a value of 1 and our hypotenuse side will have a value of 2. So this is our adjacent side, and our adjacent side has a value of 1, and our hypotenuse has a value of 2. So this is what we know about our triangle, given the information in our question stem. And now we're asked to determine sine theta. So sine theta, we know, is equal to the opposite side over the hypotenuse side. So we have the value of the hypotenuse that has a value of 2. So what we need to determine is the value of this side here. This is the opposite side to our theta, and this is the last value that we need to determine sine theta. So what we can do here is use Pythagorean theorem to determine the length of this side. So we know that the hypotenuse squared, so 2 squared, is going to be equal to the sum of both sides squared. So it's equal to a squared plus b squared, if a is this side and b is this side. So we know that 4 is equal to, well, a is just 1, and 1 squared is still 1, so it's equal to 1 plus b squared, and let's say b is the value of this opposite side. So if we're trying to bring this to this side, we're going to get 4 minus 1, which is 3, which is equal to b squared. And if we're solving for b, then b is going to be equal to root 3, which means that this side is going to have a value of root 3. And you might recognize that this is actually one of our special triangles. We have a special triangle where the sides are made up of 1 and root 3, and our hypotenuse has a value of 2. Try and pause this video and see if you guys can recall what this special triangle looked like and what the values of these interior angles were for your 1, root 3, and 2 special triangle. So if you guys remember, this is our triangle where we have 60 degrees and 30 degrees. And we know that our root 3 is the opposite side to our 60-degree angle, and 30 degrees is opposite to 1. So this theta is going to have a value of 60 degrees. But we don't need to know the value of theta for this question. That was just to recall that you guys remember your special triangles. Now we figured out the opposite side value, which is root 3. And that means that we can determine sine theta. So we know that sine theta is equal to opposite over hypotenuse, which means that sine theta is equal to root 3 over 2. And that is our final answer.